With the help of the Grable Foundation, we at IU8 are working to help our local community gain a better understanding of local industries, the kinds of employment available, and the STEM skills students are learning in school that will lead them to success in these types of jobs. Funders include PDE, the Penguins Foundation, UPMC, the Grable Foundation, and our local CSB2 Squared STEM ecosystem. The STEM Lending Center contains a wide variety of equipment, puzzles, games, and other activities that are helpful for teaching students problem-solving skills and techniques. A part of our project is to make connections between student learning and on-the-job skills that are valuable in local industries. This interview took us to J&J Truck Bodies, a division of Riggs Industries in Somerset County. Steel, stainless, and aluminum dump bodies are manufactured at the 260,000 square feet of manufacturing space. During our visit to J&J Truck Bodies, we spoke with the draftsman and took a tour of the shop to see the welding robot in action. Finally, we asked the robotics manager a variety of questions about his skills and his job. Jack began his career as a welder and then moved into the role of drafting technical drawings based on the needs of each customer.
You sort of translate between what the customer wants and how the system will make that happen.
Yes. The hands-on, the shop time. We had a wood shop in my place. That was fundamental for, using a tape, laying out different stuff, thinking through a project, blueprint reading. I'm thinking that's going to be the more desirable jobs and possibly higher pay.
The manufacturing of large metal items like dump trucks requires welding, which is a fabrication process in which two or more parts are fused together by means of heat, pressure, or both, forming a join as the parts cool. Welding can be completed in a variety of ways. While traditional welding practices are still the primary solution, options involving robotics and coding are becoming more common.
First, we start with drawings, and you get with the guys on the floor, and you're mimicking what they do with the robot, with the machine.
So is there a simulation that you're using?
It would be like it's a Fanuc Weld Pro. It's just like it's a simulated programming software.
Cool.
Using the same thing, but you're at your desk programming, making programs to upload to the robot.
Draftsman will create this drawing, okay? And on the drawing for the understructure, there's a box here. This is all the information that the robot needs, okay? So what we do is we made a program. It was like a master program. So depending on how long it is, what type of cross members, where this lift axle is, as it changes, the program changes, okay? That's big, because usually whenever you're programming, you're making that same part over and over again. We do not make the same underbody. It's built to the customer's needs.
Right.
We don't make like small, medium, and large.
Right.
There's many options. So this is the master program for Station 2. So the robots will come in. The calculation program I was talking about is right inside of here. In programming, these are variables, okay? So cross member spacing, that means the distance between this cross member and the next one. Overall length of the understructure, is given. All this is information needed for the robot to create the program that's already there, but
Just like pull the right information.
Right, so it's taking the math and dividing, taking all the calculations and dividing where these posts are in the it's called parametric programming. A lot of if statements, and so it goes home. Right here, it's going to turn the table. So it would turn this table to whatever position that is, which is 20 degrees. So here's the program it's going to run. So if it was a box short post, it's going to run this main box program for Robot 1 and Robot 2. So if it didn't, it would have jumped down and it would run the one that it needs to.
And then I was in the VOTAC for welding, the hands-on, molding, sculpting. Math is key, computer science. I want to say like warehouse, you're going to see more of it in the warehouse. You're going to see, and we have welding robots, but there's robots that glue, there's robots that pick and place, there's machining robots. We just weld. I mean, we're welding, but you're taking that same principle and just putting a different end factor on the robot. It's what it's really called.
Right.
But you see what you start with, and and really it's just steps. You just take a little bit at a time, and to the whole picture, till it all comes together. Whenever somebody on the floor comes up to you, one of the workers, and they say, "Hey, I really think that if we could put this on a robot, we could save so much more money, and we could do so much better if we just." And that's your goal, to have them, instead of saying, "Hey, I want to do this and we want to do this," is whenever they bring it to you and say, "Hey, what do you think about this?" And right now we're in the process of doing a tailgate for PennDOT. And, one of the guy that welds at the tailgates for us he says, "Brian, I don't know how we're going to do all these. Do you think what can you do on the robot?" And I looked at it and I said, "We can. Let me look into it." And so we're in the process of going to weld tailgates on the robot.
So you feel there will always be a need for actual welders as well?
Oh, absolutely. Yes, the robot. We don't weld. Machines can't weld everything. Everything that we're doing still is either fit up before it comes on a robot and finish welded whenever it comes off the robot. Because there's some things that you just you got to weld by hand. What we're doing here is we're not taking any jobs away. We're able to move these, move the people down the line into a different role. Part of the job is always challenging. If you're not challenged, you're not pushing the envelope. You're not trying to.
Absolutely.
You're gonna fail. You're gonna have stuff's not gonna work. But it's keep trying, and eventually everything comes together.
We sincerely thank Riggs Industries, J&J Truck Bodies, Jack, Brian, and several other people who helped make this production possible.